Hi everyone, and welcome back to the Seiko AI Polymers distribution blog. As always, I'm Alicia, and today I am joined by Dale Zivotech. And Dale, how are you?
I'm doing well. How are you doing this morning?
Good, thank you. So in today's video, you've prepared a presentation for us, and the topic is GT-300 as a slip agent in blown film. So you have some photos you're going to show us and point out a few things, so I'd like to go ahead and just turn it over to you.
Okay, thank you. As we've talked before a little bit about GT-300, in this particular instance, I want to talk about specifically in blown film, whereas before we talked a little bit about die drool and coefficient of friction. So to give a quick overview of the blown film process in order to understand how it affects how the improvements are made with the GT-300. In this first photo, I did this one to appreciate the overall process. You can see how many times the film goes around or changes direction, goes around rollers. I counted at least 15 in this particular drawing, but ultimately it gets to the take-up, and that tends to be where a lot of the issues are. And in this smaller photo, this one's actually a photo, the line shows only a few changes in direction, but what's important to notice here is the amount of surface contact on the rollers in themselves in the process. And these last couple graphics, the reason I chose these is the smaller one on the left shows, similar to the first one, a great number of directional changes, but this one is in a horizontal orientation. And the last one I chose because it shows where the film is on the take-up, how it could drastically improve the process if there's contact and stickiness between the film. So a common issue is the film sticks to itself, and on take-up rolls is the most common place where it sees that, but sometimes on the rollers or the guides themselves. And you can see this would cause issues in the downstream processing. And no matter how many layers of film there is on the finished product, it only affects the one from sticking to itself. So you only need to solve this problem for one material. And you can do that by adding just a small amount of GT-300 to the pellet feed of just the outer layer material. It creates more of a non-stick surface by reducing coefficient of friction on that layer itself. And since the additive is only on the outer layer, it doesn't affect any approvals for any of the inner layer of the packaging film. GT-300 itself doesn't bloom to the surface, so what you see is what you get. It doesn't change over time. It doesn't bloom and make the film any stickier or any different at all from when it's first produced. It also doesn't create any film or cloudiness or haziness in the film itself, the blown film itself. And one last thing is it releases it from itself and improves the downstream process, but at the same time, it's not a slippery film, so it's going to slide off of the guide shivs or the guide rollers or the take-up itself. And if you have any questions, you can contact myself or customer service at seikoaei.com.
All right, Dale. Well, thank you so much for giving us that presentation on the GT-300 additive. And if you're watching this video right now and you're interested in that product or any of the products that Seiko AI Polymers Distribution has for sale on their website, check out that website. You can place your order right there. And also make sure that if you need to ask any questions or get in touch with the team, as Dale said, you can do that by giving him a call or reaching out to customer service. Thanks so much for watching.